In the first part of our tutorial, we created the GUI, the background images, and we started a balloon class that would cause balloons to rise up and spawn. So we'll see here every 2 seconds a balloon will rise from about this area of the display and rise up. Now we need to implement some code that displays some feedback as the balloons cross these certain thresholds. And as well, we're going to implement some physics boundaries for objects to react against. So let's start with that first. Let's create the physics boundaries. I've got some code already copied, and I'll create the boundaries here right above the spawn balloons portion of the game.lua file. And so these boundaries are a ceiling, the ground, and 2 walls, and they're just standard rectangles that appear just off screen. And I've created these custom types, ceiling.type, ground.type, etc. And they're all given the assignment of a string wall, and this will be important when we create our bullet later. I've added physics bodies to these particular display objects, and all static because they are boundaries. And then I've inserted them into the foreground group, which is where all of the game objects are going. Now I need to connect the thresholds of the game.lua file to the balloon.lua because we want these balloons to change their point value or be affected as they cross thresholds. So remember that we created a table called thresholds, and that's holding 3 different thresholds. That's the blue, green, and red backgrounds. So let's go ahead and set up some code that will define the boundaries of the thresholds, and as well set up some code that's going to connect game.lua to balloon.lua and feed thresholds between the two. So I've got some code that I'm ready to copy and paste that sets up thresholds and their multipliers, and we're going to paste it right above the boundaries. And so here's what we do. I'll explain it. For I equals 1 and the length of the thresholds table, so that's 3 thresholds, we're defining a custom .boundary property to the current threshold, so 1, 2, and 3, equal to a rounding upwards of a value that is the current threshold's y plus half of its height. Okay, so the boundary is set here. And then we're setting multipliers for each threshold, so that for the first threshold, the multiplier is 1. And for every other threshold, the multiplier is the current value of I minus 1 times 5. So the second threshold would have a value of I equals 2. So 2 minus 1 is 1 times 5 is 5. The third threshold, 3 minus 1 is 2 times 5 is 10. Okay, so we have that set up, and we need to connect this to the balloon.lua file or the balloon class. So we'll do that by doing the following. Feed the thresholds into the balloon class. Balloon.thresholds equals thresholds. So now we're feeding the thresholds from this file into the .thresholds property of the balloon class, which now we'll create. So save this and head to balloon.lua, and we've got some work to do. So just above the new constructor here, we'll type thresholds equals then just a blank table. And this is value, or let's say thresholds fed from game.lua. Okay, so we need to create some sort of way for the balloons to periodically check for where they are on the display, and then compare that to the threshold data. And we'll do this by creating a helper function that will be called from within the new constructor. I have the code already copied for this function, and I'll paste it. It's a lot of information, but I'll go through it pretty systematically. Okay, so this is a pretty big function, but we'll go through it. So it's a helper function for comparing the balloon height, which is object 1, to the threshold, which is object 2. It's a local function. We're only going to use it within the balloon class. There's no need to expose this function outside, so that's why we use local here. And we do create it before the new constructor. That's important. So this function is called checkThreshold, object 1 and object 2, which we're going to feed balloon and thresholds in within this new constructor. So first thing we do is we want to make sure that these two objects exist. If they don't, we don't need to check for anything. Then we have 4 branches. Okay, and each branch is checking a threshold. The first branch has logic that checks for the balloon being between the boundary of the first threshold and the second. Then the second branch is between the second and third boundaries. The third is between the third boundary and 10 pixels off screen. That's off the top of the screen, so -10. And then the fourth boundary, or the fourth branch rather, is if the balloon passes this -10 pixels, then we're going to do something. And within each of these branches, I've got a portion that will allow the method to fire once, because remember, we're going to be checking this method periodically. So we want to create some code that allows for the method to fire something once and then be done with it. So what I'm doing here is I'm using the dot multiplier property that is defined here within the new balloon constructor and initially set to nil. And once the threshold is crossed, for the first one, if that threshold is nil, you'll do something. And then the next time this is checked, it's assumed that dot multiplier will change. So then the next time this fires, it will not actually be nil, it'll be something else. I have some code here in case you wanted to actually see the threshold change. You can uncomment that. So then what I'm doing is I'm setting the balloon multiplier equal to object 2's multiplier. So in game.lua, that is, let's check it out. That's here where I set the threshold.multiplier. So that's now connecting up the dot multiplier property of the balloon with the dot multiplier property of the threshold. So then that code is essentially repeated. So here within the second threshold, we are firing a method which we'll create in a minute called flash, and then we're setting the multiplier equal to the threshold multiplier. And the same with the third threshold. And when we cross after the third threshold at -10, we're calling a method called pop, which will create, it's a method that will remove the balloon. First, let's worry about this method that has yet to be created called flash. So this is a method on the balloon object, and as such, it needs to be created within the new balloon constructor. So let's go down to new balloon, and within new balloon, again, I've got some code already copied and I'll paste and we'll explain. Underneath the property declarations, I'll paste my code. Now let's look at it. So what I'm doing is I'm creating a .tween property, and that's equal to a table that has 2 other tables, a start table and a finish table. Now, within this balloon flash method that's created, I call self.tween.start, and that's the beginning of an animation. And that animation, when it's done, calls self.tween.finish. Okay, and then here self.tween.finish is then equal to this function tween back. Now that is consistent on my part. I could have easily just taken this particular function and fed it here, but this allows me to actually order them properly, and that way self.tween.finish isn't actually animating first because it's first in the code. Okay, so now what I have within the flash method are some local variables, this xs, a ys, and factor. What I'm doing is at the start of this method, I'm storing the current x scale and y scale of the balloon, and I'm setting a factor of 0.3. So at the start of the animation, over 100 milliseconds, I'm changing the x scale property of the balloon to the current x scale plus the factor, and doing the same for the y scale. Then, when the animation is complete, I go to tween.finish, which calls tween back, and that's calling a transition to self, and over 150 milliseconds, only different to have a less symmetrical look. I'm setting the x scale back to 1 and the y scale back to 1. Okay, so that's a lot of information to go to. It's still not going to work because now we need to tell the balloon to call this helper function that we created above. Okay, so to do that, underneath the flash method and right above physics, we'll type the following. So balloon.timer equals timer.perform with delay. Every 20 milliseconds, we will call a function that we're just going to create right here within the declaration. And we'll give it the last value of -1, which means that it'll continuously call this timer. We're going to call the helper function. Check threshold. The first object is balloon, and the second object is thresholds. Now this is the key right here, is that thresholds was this property created outside of the constructor and fed from the game.lua file. So that's critical. That's the way we're going to get the threshold data from game.lua into the class balloon. Okay, so we're creating a timer that is every 20 milliseconds checking the threshold. Notice that we're not canceling the timer. We don't have some sort of method yet to cancel. We'll do that later. So let me paste a comment here just above balloon.timer. And that is to start checking the Y threshold continuously using the helper function. Okay, it's a lot of code. Let's go to the simulator, cross our fingers, and press play. So no errors, and so the balloons float up, and as they cross these boundaries, we'll see the start and finish animations. So there you see the fading. And of course, we're going to get an error. You'll see it here because we haven't defined this pop method. We'll do that in a minute. Okay, so let's refresh that, and we need to create the pop method for the balloons. Okay, so we'll do that here just after flash. So function balloon : pop, and you can guess what this method is going to do. Essentially, when a balloon pops, I'm thinking of it as not existing, so we need to perform a lot of cleanup. So I've got already some code to paste. First, since we are running a timer, we want to make sure that that timer is canceled. So self.timer, self referring to the balloon, if it does exist, we need to cancel that timer. And so that's canceling the timer that is checking the threshold. So that's pretty important. Then we want to hide the object. Okay, so immediately hide the object. And then we need to set the animations to nil. That's pretty important too, just in case they're actually existing. And the animations are these two properties here. So I'll copy and paste some code. And then we also need to nil out the tween. And let's go back to the timer. I should nil this out too. So self.timer equals nil. And finally, we can do some garbage collection. We can remove the object. So we call self remove self, set it to nil, and then we can call the garbage collection to collect the garbage. That removes it. It's a way to make sure that we're accounting for objects that are no longer in use. So that's a lot of info to go through. But essentially, when the balloon pops, we stop and cancel its timer. We'll just immediately hide it. And then if either the tween.start or tween.finish properties exist, we need to nil them out. Then we'll set the self.tween property to nil, and finally remove the object from the display and set it to nil and call garbage collection. Okay, let's go ahead and test this in the simulator and see what happens. So the balloons will rise up, and when they cross the threshold, we'll see the balloon : flash method. and when they reach -10 pixels, their pop method will be called, and we'll look for errors, and we've got no errors. Everything is running smoothly. So now it's time to create the bullet class, and the bullets will be what we fire to pop the balloons. So we'll close the balloon.lua file, head back to game.lua, and head to the top, and we'll go ahead and create a reference to a class that we're going to create here in a minute. Local bullet equals require, open and close parentheses, bullet. Now we haven't created this yet, so obviously if we ran it, we would have a problem. And just as we have a table to hold the balloons, we'll have a table to hold the bullets. Local bullets equals an empty table. Okay, so now let's go ahead and create the bullet.lua file. File, new file, an empty file, and call it bullet.lua. And we'll place it in the project folder. Finish. And since it is a module, we need to have that first line of module, module package.call. And our constructor will be function new bullet end. Okay, I have some code that I'm ready to paste. So local bullet is an image, and we need to make sure we return bullet. So it's a new image of a bullet, and it's got its initial X and Y set. And let's go ahead and paste some properties. So I set the type, custom property to bullet. This will be used for collision detection. I apply physics to it. I add a body to bullet. That's a kinematic body type, and we're going to be changing that when we touch the bullet. And I set some initial properties. Notice that the radius is equal to 20. That's because this image has a radius of 20. I set some linear and angular damping. This was just done through some testing, just continually testing the physics of the bullet, and this seemed to work fine. Then really important is that we're going to make the bullet a .isBullet. Now that is a property of physics to true, so it forces continuous collision detection. And as well, we're going to set it to be a sensor so that it'll pass through balloons and hit multiple balloons. So now we want this to have some functionality similar to Angry Birds, where you touch and hold and drag your finger backwards, and that affects the amount of force applied to the projectile. In Angry Birds, it's birds. Here it is a bullet. So we're going to create an event listener for the bullet and apply lots of different physics properties when the touch is released. So first, bullet add event listener, and we'll listen for the touch event, and we'll call the method on the bullet itself. Then we are going to create the function for listening to the touch. So function bullet :touch end. Okay, so I've borrowed some code from the Corona pool example, which creates this really cool line when you touch the cue ball and release. And so I'm going to implement that so that way there's some feedback as to when you touch the bullet and draw your finger back, you can see a line connected from the initial touch point to, or the center of the bullet to then where the finger is. That'll help the player realize the, or gauge the amount of force that'll be applied to the bullet visually. Okay, so I'll go ahead and copy and paste some more code. So first, the local t is going to be equal to e.target, and that's the bullet. Then we need to form the began phase. Okay, notice I haven't ended that. So if the phase is began, then we are going to set the focus of the touch to the current object. So that'll let us continue to register the touch as the finger goes outside of the object. We'll set this custom isFocus property to true and make sure that the body type is set to kinematic. Otherwise, the bullet will fall when it's instantiated, and we don't want that to happen. If there's any motion at all, we want to make sure it's set to 0, both in the linear velocity and the angular velocity. Then this myLine is equal to nil. We're actually going to create myLine here in a moment, not in the began phase. Okay, so then we haven't yet closed this condition. We'll do that here, okay, by else if the object already has focus, then we need to do a bunch of things. Okay, so within this particular branch, we will have if e.phase double equals moved, then else if e.phase double equals ended, or e.phase double equals canceled, then end. So obviously if the finger's moving or if the finger is done moving, we'll have code. So now if the finger's moving, that's where we want to create a line. So I'll copy some, paste some code. Again, I got this from the pool example in the sample code of Corona. So if myLine exists, then we're going to remove it and then draw a new one. So what's happening is every time the finger moves, the previous line is removed and then a new line is drawn. It may seem inefficient, but that's actually pretty standard in programming, to remove something and then create it, but you're doing it at such a fast frame rate, the player can't tell that it's actually a line that's being destroyed and created every frame. So as we move the finger, we're destroying and creating a new line. And then at the ended phase is where all the magic's going to happen in terms of gauging the velocity and sending the projectile forward. So I've got more code, and we'll copy and paste it. Okay, and let's go ahead and go through this. So what we're doing at the end of the touch is we're releasing focus, and we're setting the isFocus property to false. We don't have this audio .play. We haven't set that yet, so we'll put that in a minute. Now, if the line exists, we need to remove it from sight, okay? And then we need to launch the bullet. So here we change the body type of the bullet. Remember that self is referring to this bullet, to dynamic. And then we're applying force. And this is the equation for applying force. So the x times the multiplier on the x, and the difference between the x and the y times the multiplier, and then it's being applied to the self x and self y. So you might want to pause it and write that down. So then we're waiting just a moment. Actually, we don't need that. This is a sneak preview. You don't need to see this just yet. So we're not yet employing the state machine, getting ahead of ourselves. Okay, so we'll save that. And so far so good. We have bullet : touch is this gigantic method here. And at the beginning of the phase, set the focus, set the property of focus to true, make sure the body type of the bullet is kinematic, stop any kind of motion if there is any, and then myLine is set to nil. Well, myLine is actually created in the moved and ended. Remember that we're recycling this way. So now if the touch is the focus, then when it moves, we're destroying any lines that are created and creating new lines where the lines are equal to the start from the position of the bullet to wherever the finger is. Then when the touch is over, get rid of the focus, set the focus property to false. We commented out this audio because we haven't gotten to that yet. And then if the line exists, destroy it, and then launch the bullet. And here's the code for launching the bullet. We set it to dynamic, the body type, and then apply a lot of force. So obviously I know you want to see this thing launch, so we'll save it and head back to game.lua, and we need to call a bullet. Okay, so just as we spawn the balloons, Well, let's create a single bullet, then we'll worry about creating a spawn bullets function. Local b equals bullet dot new bullet, and then actually that should be just fine. Let's create the simulator. There's our bullet, and now as you can see that white line, that's from the pool, and you can see that the bullet just fell. Looks like we've got a problem, and let's take a look at the terminal. Attempt to perform arithmetic on global force multiplier. We need to create the force multiplier property. So let's go back to the bullet class, and we're going to create that outside of the constructor, so that way we can feed it from game.lua. So force multiplier equals, and let me look up the value. Okay, save it, and let's go back to the simulator, relaunch. Okay, I'll draw my finger back, or at least the simulation, and there goes the bullet. So now we can create a method to spawn multiple bullets. Okay, so let's go to game.lua, and just as we created a spawn balloons method, let's create a spawn bullets method. Local function spawn bullets, and the number of bullets. And it's very similar to spawn balloons, except we'll just go ahead and spawn all of the bullets at once. I've got some code to paste, and here I use total instead of number, so let me be consistent, total. So spawn bullets with the argument total for I equals 1, for however many bullets we want. This bullets table that we created at the top will store all of the spawn bullets. And we're saying that as we go through, the first index will equal a new bullet, and we'll flag the bullets for removal, which is what we did with the balloons. We have yet to implement that. And then we'll insert the bullets into the foreground. Okay, let me, instead of calling this local b equals new bullet, let's call spawn bullets, and let's spawn 5 bullets. Go to the simulator, refresh it, and play. So now I should have 5 shots. 1, 2, 3, 4, 5, and then all of the bullets are gone. Now, I haven't coded any collision detection. That's what I'd have to do next. So if I actually see it passes through the balloon, so now we actually have to code the magic of the bullet colliding with either the balloons, or remember that there are walls here on the outsides, because we want to get rid of the bullet. Actually, right now it's still flying in all of this space off the screen, and poor things need to be handled. Okay, so to do this, we will go to the balloon.lua, or sorry, the bullet.lua file, and code some collision detection for the bullets. Okay, we'll go to the bottom of the code, and just above the event listener for touch, bullet add event listener, and we'll listen for collision. And we'll create the method on itself. Okay, and just above this line, we'll type function bullet collision, 1s, and the E represents the collision object return. Okay, and here we have some code ready to paste, and I will go through it. Okay, so the collision has 2 phases, began and ended. And so whenever a collision is registered on an object, here the bullet, we'll use self to refer to the bullet, and then e.other to refer to the object it was collided against. So in the began phase, if e.other, which refers to what is collided against, is of the type balloon, then we'll do some stuff. And you can't yet see this state machine. Don't want you to see that just yet. So if it collides with an object that is .type balloon, then we'll perform some magic. If it collides against the wall, we could do something else. Well, actually, we're not going to do anything. At the ended part of the collision, if it collides with the balloon through this audio.play pop, which isn't ready, if we wanted the bullet to disappear upon collision, we could call this commented portion. We don't actually want it there, but I'll leave it there just in case you want to copy it and try it out. And then this is really critical. At the end of a collision, if it collides with the balloon, we're going to call that balloon's pop method. That will cause the pop method to fire, and we created that so that the balloon could essentially disappear, remove itself, etc. All right, and then if the bullet collides with a wall, then we'll just remove the bullet and set it to nil. Okay, so save it. We're not setting it to nil when it collides with the balloon because we want the bullet to pass through multiple balloons. We set it to nil only when it collides with a wall. Save that, and let's go ahead and implement this audio that is the popping sound. Head to the top. I've got some code to copy and paste, and we'll paste it here under classes. So these are sounds, shot and pop. So audio.loadSound, shot wave, and pop wave. Let's go to bullet.lua and go ahead and uncomment audio.play pop. And there was another one, audio play shot. Okay, let's test this out in the simulator. And now, when we have the collision against a balloon, it should remove itself, and it's gone. And as well, you can hear the firing of the balloon. Actually, let's see. Let's do that again. I forgot one more thing. Because audio is not a global here in game.lua, just as we passed all these references between the game file and the classes, we need to pass a reference of the audio files to the bullet. So what we'll do is pass the sounds to the class. Okay, and that's done by the same way we pass the thresholds to the balloon, and we pass anything to a class. Is we're referring to a property of that class that we'll just create in a minute, and then the local variable. So let's go to bullet.lua, and up here above the constructor, we will create shot and pop. Okay, now let's run it again. Okay, now you can hear it. And when I hit a balloon, it pops. Okay, so far so good. We've got the balloons rising, they're checking their thresholds, we've got the bullets firing, and they are destroying the balloons. We can see feedback in terms of a line when we drag back in this sort of Angry Birds style firing of the bullets. And now we need to create the game logic, and we'll do that in the next part of the tutorial. For a small fee, you can download the project files for this tutorial at cheetomoskeeto.com.